Hi, I'm Saji, and today I'm gonna talk to you about the information of all science. The mighty atom. All matter is made up of tiny particles called atoms. These are smaller than you can possibly imagine. One raindrop contains about 6 billion trillion of them. For years, scientists thought atoms were the smallest things possible. But then they found even smaller particles inside atoms, and a strange new world opened up. Inside the atom, every atom has a solid center called a nucleus. It's made up of two kinds of particles, protons and neutrons, whizzing electrons, which are trapped by an electric pulling force from the nucleus. People once thought electrons orbited the nucleus like flying balls, but the truth is stranger. An electron is never really in one place and can be in lots of places at once. It can also leap from one orbit to another without passing through the space in between. Empty space. The nucleus takes up only 1 millionth of a billionth of the space in the atom. If the whole atom were the size of a cathedral, the nucleus would be a fly. Since electrons are even smaller, an atom is almost entirely empty. If you could remove all the empty space from every atom in your body and everyone else's bodies, then the entire population of the earth would fit inside a sugar cube. Molecules. Atoms sometimes share electrons with other atoms. When this happens, the shared electrons form a bond. Fastening the two atoms firmly together, groups of atoms held together by bonds are called molecules. A molecule can have as few as two atoms or as many as a million. Float a paper clip. Float a paper clip. If you're careful, you can float a paper clip on the skin that forms on water due to attraction between its molecules. Place a paper clip on the tip of a fork and lower it onto the water. If you touch the water with a soapy finger, it will destroy the skin and the paper clip will sink. Shapeshifters. If you warm up ice, it melts and turns into water. If you heat water, it boils and disappears into the air. Like most things, water can exist in different physical forms: solid, liquid, and gas. We can call these states of matter. Vanishing water. Solids. Solids. In a solid, the molecules are packed together neatly and strong bonds hold them in place, giving solid objects their shape. If you heat up a solid, the molecules jiggle around until they start to pull apart, and then the solid melts. Liquids. The molecules in a liquid are held together but can slip and slide around each other. A liquid has no shape, and you can pour it into any container. If you heat it up, the molecules will jiggle faster and faster until they fly away. The liquid becomes a gas. Gases. Gas molecules zip about freely as there are no bonds holding them together. They fly apart and fill whatever space they're in. When you boil water, it turns into gas and escapes. The mist from boiling water is caused by the gas turning back into the tiny liquid droplets. Vanishing water. When water turns into a gas, it vanishes. We can't see it anymore because the water molecules are hidden in the air. When water disappears into the air, we say it evaporates and turns into water vapor. which is invisible. If you make water hot enough, all the water molecules try to evaporate at once and the water boils. The water cycle. The water on the Earth's surface travels in a never-ending cycle, changing from solid to liquid to gas and back again as it travels. Seawater evaporates and rises and forms clouds. The water then falls back to Earth as rain or snow and flows back to the sea again. Condensation. Air always contains invisible water, vapor, especially on muggy days. If the air gets cold, the water molecules turn back into liquid and reappear as tiny droplets. When this happens on a cool night, dewdrops appear. Water vapor can also condense in midair to make clouds or fog. Mixed up. What do mud, mayonnaise, and air have in common? They are all mixtures of chemicals. Pure chemicals, such as water or salt, contain only one type of molecule. Mixtures are a combination of different molecules. So thank you for listening, and just continue that in chapter 2. Okay, thank you.